Okay, so again, we're doing 5.1. You guys get a nice little view right there, and I'll just keep being loud. The first part is actually good because we know how to do this first part. This is like chapter 4, actually, these first two problems. And then when we get to number 2, we're going to have to kind of sidebar off to something new. The first problem says, find sine of theta and cosine of theta if tangent of theta equals 3/4, and then sine of theta, that should be is greater than 0. We've done problems like this, actually, pretty recently. If tan is positive, what quadrants could that be in? Where could tan be if it's positive? 1 and 3, good, Whitley? What about where can sine be if sine is greater than 0?
1 and 2.
1 and 2, very good, Brooke. And then where's my overlap? 1. Quadrant 1. So I'm going to go off to the side. I'm going to draw my triangle in quadrant 1, and I'm going to label, if tangent is 3/4, what do 3 and 4 mean on my triangle? Tangent is what over what?
Opposite over here.
Opposite over adjacent. Good, Willie. So I'm going to go use that for my triangle over here. I like using this as a mark. Got my triangle in quadrant 1. Got my theta, got my right angle. There's my opposite, there's my adjacent, here's my hypotenuse. Now we know that it's tangent, they told us was 3/4. 3 is my opposite, 4 is my adjacent, and then we got to find my hypotenuse. How do I do that?
A squared plus b squared.
Awesome, Brooke. Pythagorean theorem, 3 squared plus 4 squared equals x squared. 3 squared is 9, 4 squared is 16 equals x squared. And then I've got 9 plus 16 is 25 equals x squared. Ooh, this will be nice. Square roots perfectly and I get 5. Okay, and all I want to do now is find sine and find cosine. So what's sine of theta?
3/5.
3/5. What about cosine?
4/5.
4/5. 3/5, 4/5. All right, how are we doing with that? Pretty good, right? Not too different, not too bad. All right, the next one's very similar, except this time we're finding sine and tangent, and I'm going to give you cosine is positive 4/5, and tangent is less than 0. Okay, so now we got to figure out what quadrant we're in this time. So cosine is positive, so where's cosine positive?
1 and 4.
1 and 4. What about, where's tangent less than 0?
2 and 4.
2 and 4. Anyone have questions on how Brooke got those? Everyone's okay with that? Sometimes with tangent, I think like, okay, where is tangent positive? And then I just do the opposite one. So we know tangent is positive in 1 and 3. So then the opposite ones are 2 and 4. That means that my overlap here is in quadrant 4. So I'm going to go over and graph in quadrant 4. Last class, someone was asking something about like, do we have to do it in, like, why do we have to know the quadrants? In a second, we're going to have a negative value, and I think it can be tough to recognize if you're, like, if you have a negative, if you're not in the right quadrant. So I'm going to make sure that I'm in quadrant 4, and I'm going to do my right angle, and there's my theta, opposite, adjacent, hypotenuse. My adjacent is 4, my hypotenuse is 5. Whatever my opposite is, it's going to be negative because it's going down. Everyone okay with that? Let's do Pythagorean theorem to find it. I get x squared plus 4 squared equals 5 squared. X squared plus 16 equals 25. Minus 16, x squared equals 9. Oh, nice, another easy answer. X equals 3. Since I know it's in quadrant 4, though, I know it's a negative 3. Negative 3. Okay, Now we gotta do sine and tangent. What's my sine of this theta gonna be? -3/5. And tangent's gonna be
-3/4.
-3/4. Good will. So those two problems actually were ones that we've done before. We just did actually a lot of those types of problems last unit. Everyone doing okay so far? Okay, now I want your unit circle out, and I'm going to tell you some new like reference things we're going to put on our unit circle. These are called identities, and if you try to look at number 2, I don't know where to go yet because I haven't given you any tools to work with. So go to your unit circle, flip it over to the back. You can write this on a separate sheet of paper. I just like one piece of paper that I know is important, not 17, so that I don't have to keep track of all 17 of them. And we're going to do a couple things all together. I'm actually going to leave this written up on the board, the ones that I have right now. So the first ones we can call basic, or I'm going to actually call them the reciprocal identities. I kept using the word reciprocal last period, but I forgot to label them that way, and I think it's better if we just label it as the reciprocal identities. These are ones you actually should already know. So we know that sine and cosecant go with each other. We know that they're just the reciprocal of each other. So now we're going to physically write it as reciprocal. So sine is the same thing as 1 over cosecant, and then similarly, cosecant is the same thing as 1 over sine. So again, I would argue these are not brand new, but we haven't physically written them out like this, so I wanted to make sure we got the chance to. Same thing with cosine and secant. We know secant and cosine go together because, again, they are the reciprocals of each other. So if I'm flipping cosine to be 1 over secant, and secant becomes 1 over cosine. Flip, flip, flip. And then same thing with tan and cotan. Any questions so far? Make sure this is written down if it's not already. Again, I'm building a toolbox right now with you guys, and if you are missing a tool, you're gonna have a really hard time with what we're doing next. Now, in addition to this, I'm gonna write one more for tangent and cotangent, okay? Tangent, I'm going to say it's the same thing as sine over cosine. If you have earlier up on your page, you don't have to write what I'm about to write in dark blue. Tangent, we knew in the unit circle was the same thing as y over x. What's y on my unit circle? Anybody? What's y on the unit circle?
Sine.
Sine. What's x on the unit circle?
Cosine.
Cosine. So we, and I'm going to scroll back to this, but for a long time we wrote tangent was y over x. You guys knew that. So now I'm just putting sine and cosine with my y over x, so that instead of just writing tangent as 1 over cotangent, actually the one I'm going to use more often is writing tangent as cosine, or sorry, as sine over cosine. Similarly with cotangent, I can replace that with cosine over sine. Just again, reciprocal flip. Everyone okay with that? You don't quite know what we're doing yet, again, but we're building a base. And if we don't have a base, we're not going to be able to do anything in a minute. So we're getting getting set to go. Okay, the other things, I've got 3 more that I'm going to teach you. And I'm actually going to erase these. I'm going to write them with you guys. These are called Pythagorean identities. So write Pythagorean identities, and we're going to write 3 of them, but each of them have 3 different pieces. I don't want you to freak out, though, that it looked like a lot that I just erased, because there's only one individual one, and then we just rearranged it. We just kind of shuffled it around for the other 2. Okay, a brief explanation of the Pythagorean identity, and you can just watch and listen. You don't have to ever reciprocate this, and I could spend way more time on this if possible. If we know that we have like our unit circle, I've got any point out here, and my x is the cosine and the y is the sine. We're okay with that, right? We've done that before. If I were to draw a triangle from that point, ooh, better one would be cool. But if I draw a little right triangle from there, I've got a right angle. My x, or my horizontal value, is that cosine. And then my y is the sine, that's my vertical distance. And then in the unit circle, my hypotenuse is just 1. So if I were to do Pythagorean theorem here, I would do sine squared plus cosine squared equals 1 squared. So our first Pythagorean identity is just that. Sine squared of x plus cosine squared of x equals 1. You can write x or theta, it doesn't matter to me. But if you see sine squared of something plus cosine squared of the same thing, that is the same thing as just 1. Now, I've got space for some more underneath it because I'm just going to shuffle it around. What if I minus my cosine to the other side? What if I move my cosine to the other side? That would give me sine squared of x equals 1 minus cosine squared x. We okay with that? It's the same thing, I just rearranged it. Similarly, and from the beginning, I could have moved sine instead of cosine. That would have given me cosine squared by itself, and I would have had 1 minus sine squared of x. So even though this looks like 3 identities, it's just one written 2 different ways. Does everyone see how I'm just rearranging it so it looks like different things? We're okay with that? Okay. The next one, the next 2 Pythagorean identities come from these, and it's if I were to divide, the first one would be if I divided by sine squared. So don't write this down, just kind of watch me. If I took this exact thing, see if I can copy that. If I copied that, too much, that's okay. If I were to take all of these and divide them by sine of x, so technically nothing changes. The value is still the same. When you divide by everything, that's okay. That would give me 1 plus, a minute ago, we just said cosine over sine is cotangent, and then 1 over sine is cosecant. So don't write this part, but write the new blue thing I just wrote. I'm just showing you why I got that. So the second Pythagorean identity is 1 plus cotangent squared equals cosecant squared. Again, this is the y, but you don't have to worry about that. And again, I'm going to write it 2 more ways where I just move things around. So I'm going to minus the cotangent from both sides. So 1 equals cosecant squared minus cotangent squared. And then the next one, I'm going to move the 1. So I'm going to get cotangent squared of x equals cosecant squared of x minus 1. Okay. Again, we don't know what these tools are yet. We're just writing them down so we can use them later. But does anyone have any questions on how I rewrote any of those? Mm-hmm. So now you should have 6 of them written down. The last one I'm going to derive from the first one again, but instead of dividing everything by sine squared, I'm going to divide everything by cosine squared. So I'm going to go write that, and then I'll come back if anyone is missing anything. Again, you don't have to write this purple stuff. I'm now dividing everything by cosine squared, so I can prove to you on why this works. Might be like super nerdy, but like I majored in like math and all I did was prove. So like I have a lot of like experience with this. So like you might be like, why is Miss White showing us all this background? It's because I think it's interesting and because I think that like you shouldn't just like see something and memorize it. I think you should understand why it happened. So like this is okay to do because I'm dividing everything by the same thing. So sine divided by cosine is tangent squared. Cosine divided by itself is 1, and then 1 over cosine is secant. So what you'll need to know is this is the last Pythagorean identity. Tangent squared plus 1 equals secant squared. And again, we're gonna rotate that around. We'll start by moving the 1 over, so that's the same thing as tangent squared of x equals secant squared minus 1. And then I'll move the tangent over and say 1 equals secant squared of x minus tangent squared x. And now that I've proven my point, I'll get rid of some of this nonsense. So again, you don't have to have the y, I just like to show it to you. This is like when we first learned like sine and cosine, when we wrote like SOHCAHTOA at the top of every page to remind us that like sine was opposite over hypotenuse, to remind us that cosine is adjacent over hypotenuse. Now I've got other identities, so when I see like sine, I know it's opposite over hypotenuse, but I also know now if I see sine squared plus cosine squared, that equals 1. Okay? I'm not going to be able to have this up at the same time that I have my notes up, but I'm going to go back to my notes, and I want you to keep your toolbox out. Keep this like kind of side by side what we're looking at, because we're going to reference back to this, okay? Everyone good so far? Do I need to keep it here for a second? Yeah. Okay, 1 second. The next thing we're doing is simplifying things. So I want everything in terms of sine and cosine if possible, and I want no fractions if possible. So there's always an exception, but that's kind of our goal for the next round, is to get things in terms of sine and cosine and to get all of my fractions gone if I can do that. All right, can I move on? Yes. Okay, here I go. So I'm on the simplified part. So there's a few problems here where we're just simplifying. Okay, so this first one says tangent of x times cosine of x. I would love to start by getting everything in terms of sine and cosine. So can I rewrite tangent in terms of sine and cosine? What's tangent the same thing as?
Sine over cosine.
Sine over cosine. So instead of writing tangent, I'm going to write sine of x over cosine of x times cosine of x. You could think of that as cosine of x over 1. Hope everybody's with me. And now that I'm here, do you see how I've got a cosine on top and on bottom? I can cross those out, and I get sine of x over 1, which is just sine of x. That's it. I simplified out tangent to be sine over cosine, and then I canceled out my cosine, so I was left with just sine. Cool? That's all we're doing. Any questions so far? Now, obviously, it's going to get a little bit more, we're building up, but do you see kind of our goal? We want to end with like 1 term or 2 if we have to, and I want things in terms of sine and cosine. All right, letter B, I've got 1 plus tangent squared x over cosecant squared x. Oh, yikes, this looks funky. Do you see anything on your paper that looks like what I have right here?
One plus cotangent x replacement cosecant.
I'd rather go the other way. Can you replace 1 plus tangent squared with something?
Secant squared.
Secant squared. Do you see that in your third, I think, Pythagorean identity? So Willie said, well, can we replace cosecant squared with 1 plus cotangent squared? And I said, I'd rather go the other way. I'd rather just have 1 term, not 2 over 2. So if I replace 1 over tangent squared with secant squared over cosecant squared, this already is starting to look a lot more simple. One of your Pythagorean identities literally says 1 plus tangent squared equals secant squared, so we just substituted.
Where does it say that?
Your third Pythagorean identity. Says this equals secant squared. You find it?
I don't have the 1 plus.
You should have 1 plus. It looks like I wrote tangent squared plus 1, but you know pluses are.
It looked.
Oh, that'll get you. That'll get you. So now I've got secant squared over cosecant squared. Again, I told you I want things in terms of sine and cosine. Can we rewrite secant squared as something in terms of sine or cosine? What's secant squared in terms of sine or cosine? What's secant the same thing as in terms of sine and cosine? Cosine. So secant by itself is 1 over cosine x. Secant squared is 1 over cosine squared x. So I'm not going to make a list of cosine squared and secant squared and all that stuff. We're just going to assume that the exponent follows us all the way through. What about cosecant? What does that go with? Sine. So cosecant squared is the same thing as 1 over sine squared of x. Now we simplified at the beginning by getting rid of the 1 plus tan squared to secant. Now I made it a little bit more complex. I'm not done because a fraction over a fraction is not simple. How do I get rid of a fraction divided by a fraction? By? Very good. Multiply by the reciprocal. So I'm going to do 1 over cosine squared x times the reciprocal sine squared x over 1. Yeah. And then I don't have anything I can simplify out. I'm just going to do sine squared x over cos squared x. But I can go one more step. Can I rewrite sine squared over cosine squared as just one trig function? Which one? Tangent. I know that we've got tangent equals sine over cosine, but tangent squared equals sine squared over cosine squared. And that's it. We got all the way down to one term. We did it. So we had to use our Pythagorean identity here. We used our reciprocal identity to go from step 2 to step 3. I multiplied by the reciprocal, and then I had just one last step where I simplified down from sine over cos to be just tangent. Anybody questions on what I've done so far?
Wait, no, I thought you wanted it in terms of sine and cosine.
So when it's sine over cos, we'd rather it be tangent. If we can write it as just one trig function instead of a fraction, we're going to do that. But the ultimate goal is sine and cosine. Good question, Kate. Good clarifying question. All right, ready for C? Okay, I've got sine squared of x or negative x plus cosine squared of negative x. Does that look like anything on our paper? Even a little bit?
The first Pythagorean.
It kind of looks like the first Pythagorean, right? Except this time I've got a negative x. When I say something like x, if I say sine squared of x plus or plus cosine squared of x, that can be anything. It can be the same number, it can be the same variable, it can be a banana for both of them. Like, I don't care what it is. It can be the same thing for both of them. So it doesn't matter that it's negative. It's still that first Pythagorean identity. So sine squared of anything plus cosine squared of that same thing is always just 1. Doesn't matter if it's negative, doesn't matter if there's a value there or if it's x, it doesn't matter if it's a drawing, I don't care what it is. It's the same thing, so it's 1. Let's do E while we're here, and then we'll move over to do D. So E says secant squared of V minus tangent squared of V. Again, same idea. V is just your x. V is just a variable, so you don't have to worry about that meaning anything different. And then divided by cosine squared of x plus sine squared of x. Do you see secant squared minus tan squared anywhere on your paper? What does that equal? 1. Willie says the top equals 1. What's cosine squared of x plus sine squared of x the same thing as? 1. What's 1 divided by 1? 1. That was an easy one. How are we doing with that? Do you see we just did a little search and find on that? So we had a tool, we replaced it. We had a tool, we replaced it. If we can simplify it down to one thing, like 1 or cosine, we're going to do that every single time. All right, D, there's a little bit more space because there's a little bit more work with this problem. Any questions before I go to D? Okay. D says sine of x parentheses tan x plus cotangent x. I can think of a couple different places to start. Does anyone have a preference or have an idea on what we can do first? What can we do first?
Distribute.
We could distribute first. So I'm going to distribute sine of x inside. So that gives me sine x times tangent of x plus sine x times cotangent x. I'd make us distribute eventually, so distribute now works. It didn't really let us do anything though. What else do I need to do in order to start like simplifying? What's another thing I could do here? Can I combine anything right now? I can't add anything together, can I? When you get kind of stuck, I'd say, okay, can I rewrite something in terms of sine and cosine? Is there anything here I can rewrite in terms of sine and cosine? Can. What's tangent the same thing as in sine and cosine? Sine over cos. So I just use a little dot to multiply them together. And you can make it sine of x over 1 so that you recognize that there's no denominator there. And before I simplify or multiply or anything crazy, what else can I rewrite? Cotangent as?
Cosine over sine.
Good. Cosine over sine. Very good. Very good, Aiden. All right. Now we're going to start simplifying or multiplying. On the first one, I don't have anything I can cross out or simplify. I just have sine times sine and then 1 times cosine. This isn't cross multiplication. When two fractions are being multiplied, the tops go together and then the bottoms go together. So I'm just going to do sine times sine, which is sine squared, over 1 times cosine, which is just cosine. The next one that I can cross something out, do you see how there's a sign on both top and bottom? We're going to cancel that out, and so we're going to be left with cosine on top and then just a 1 on the bottom. We good so far? Everyone with me? Okay, can I combine those two fractions? Can I combine them yet? No. You gotta get like denominators if you want to combine because now I'm adding. When I was multiplying, you can multiply all day, but I gotta add them, so I gotta get like denominators. What do we want to multiply on top and bottom to the second one to get a like denominator?
Cosine.
Cosine, very good, Kate. Cosine on top and on bottom. So the first fraction doesn't change yet. I still have sine squared over cosine. What's that? Okay, go get the pass and then come back. Multiply by cosine on top and bottom. Now, some of you might have thought to do this step already. I just haven't. My next step would be to combine them into one fraction. Did anyone already do that? Some of you guys might have already done that. So I'm going to do sine squared x plus cos squared x over cosine. Can I simplify with the cosines here? Can I cross out a cosine on top and bottom? No one seems to commit to an answer. The answer is no. We cannot cross these cosines out here. Does anyone know why I can't cross these cosines out here? Say again? That's not why.
Because the top equals 1.
That we're about to use that, but that's not why. If I have a plus sign, we don't get to cross anything out. So it's only when they're multiplied. So if it was sine squared times cosine squared, you could cross those out all day, but not when they're being added. But I do like, Kate, what you just said, because you were going to do sine squared plus cosine squared equals 1. So I'm about to write 1 over cosine of x. I did not do my work very organized today, but please just bear with me. Sine squared plus cosine squared equals 1. And I'm going to go one more step because, again, I don't want fractions if I can help it. What's the same thing as 1 over cosine? Secant. So all of this gets all the way down to secant of x. That really helps. That's pretty cool, wasn't it? Yeah, no? Maybe? Half of people aren't listening to me. The other half of you are like trying to stay awake. That's okay, it's what it is, but I think this is so interesting and I wish we could spend way more time, but we are not going to spend that much time on this stuff. But does anyone have any questions on what I'm talking about right now? Everyone okay with how we got to secant? You're just using your tools. We're using our little toolbox on the back of our unit circle. All right, let's keep rolling. We are not going to do G for today. I'll figure that out and do that another day. I did not figure it out before today. And I don't want to just struggle my way through it. That's a waste of your time. So we'll do that another time. Let's do letter F, and then we're going to do a whole new concept, okay? So letter F. 1 plus sine squared plus secant squared over tangent squared. Any ideas on how I should start? Are you saying Pythagorean identities right now? Does match any of my Pythagorean identities? No, doesn't match any of the Pythagorean identities, not yet. If I had 1 plus secant squared on top, that'd be a different story, but I don't. If I had, those things on all together, it'd be different, but they're not. Instead, can we make secant and tangent in terms of sine and cosine and then kind of see where we go from there? What's secant the same thing as in terms of sine or cosine? 1 over cosine. What's tangent the same thing as in terms of sine and cosine? Sine over cosine. Now, I didn't say squared for all of these, but we're assuming that like the beginning part was squared, so we're going to bring a square with us. Thank you. Do I get to keep this, or do you need to swap out of the building? Perfect, thank you. Again, I didn't say squares, but bring your squares with you. Everyone okay with that? All right, now I'm going to get rid of that fraction over a fraction. How am I going to do that? Multiply by the reciprocal. Very good. So I've got 1 over sine squared of x plus 1 over cosine squared of x times cosine squared of x over sine squared of x. So that's like really messy for no reason. Let me try this. As we notice, though, we're going to have a cosine squared that we can cross out of both sides. So I've got cosine here, can cross out. So that just leaves me with 1 plus sine squared on the right fraction. I have not done anything with this sine 1 over sine squared this whole time. He's just hanging out, doing his thing. What should I do next? I don't know. Can you add 1 plus sine squared over 1 plus sine squared? Yeah, what is that going to be?
2 over sine squared.
2 over sine squared. I got one more step though, because I don't want a fraction. By
Sine squared of x.
if we multiply the bottom by sine squared x, we're going to get sine over 4, or sine to the 4th over x. What's 1 over sine the same thing as? If sine's in my denominator, which other trig function is that? Cosecant. So to get rid of the fraction, we just convert this using our reciprocal function. So it's going to be 2 cosecant squared of x. So sine 1 over sine becomes becomes cosecant. Carry the 2, carry the square. That's it. The end. All right. Questions on that one? Nope. No, we're doing okay. Okay. Again, we're gonna skip G just for sake of time, and because I don't remember how to do that one off the top of my head. The next skill we're gonna do is solving equations. So we're not technically using our trig identities that we just learned, but we are gonna use a unit circle. So flip your unit circle back over. We're gonna reference the front side of this now. Okay, this one says solve where 0 to 360 is my x domain. So I want all of my answers are in this domain. They fit in here. So we cannot include 360, we cannot go bigger than 360, which we don't really want to anyway, so that's okay. And we cannot have any negative angles. So all of our angles are positive between 0 and 360, but do not include 360. Okay, so all my answers right now are going to be in degrees. If you look down to number 4, do you see how it goes from 0 to 2 pi? That now means that I'm in radians. So if we get to number 4, we're going to be in radians, but for right now, we're still in degrees on number 3. This problem looks super confusing. I've got 2 cosine x sine x minus cosine x equals 0. However, if we treated this like an algebra problem, we're just going to find a common factor, bless you, and factor it out. So what's a common thing that you see in both of those pieces? And say again?
Cosine.
Cosine. I've got cosine here. I've got cosine here. You can take cosine x out of everything. When we divide by cosine x from the first one, I'm left with just 2 sine x. If I divide cosine by cosine, I'm left with just 1. Gave myself way too much room. Now I just spent a ton of time doing factoring with my geometry kids. This is like a factoring problem where I tell them that you have to set each factor equal to 0, right? You guys remember that when you first learned how to factor. So I'm going to do cosine of x equals 0. And I'm going to do 2 sine of x minus 1 equals 0. Now, this is why we just learned 4.7, our inverse trig functions, because my answer here is going to be an angle. I'm essentially saying at what angle is my cosine going to be 0? So I'm looking at my unit circle, and I want to know where my cosine is 0. If my cosine is 0, what value are you looking at? What are you looking for?
X.
X to be 0, right? So where is your x 0?
90 and 270.
Good, 90 and 270, pi over 2, pi over 3. The domain tells us we're in degrees, so we're going to write our answer in degrees for today. We're going to say 90 and 270. That's really all the work that needs to be done right there. X has to equal 90 and 270 in order for my cosine to be 0. Now the next one, I got to do a little solving first. So I got to get sine of x by itself first. Let's add 1 to both sides. We got 2 sine of x equals 1. And then we got to move the 2. So let's divide by 2 from both sides. And so now I'm asking myself, at what angle is my sine 1/2? 30. And then I think there's one more. 150. So now this time we were looking for where my y is 1/2. Write my answers out nicely off to the side, just all together. I like to go from smallest to biggest, so I write 30, 90, 150, 270. The other class is like, do you have to do that? No, that's just a weird thing I do, just because I want my answer to be clear. The only reason I would say definitely do that is if I don't know what your answer is, I can't give you points. So you got to make sure that you know, that you tell me you know what's going on. So x equals. All right, that's all we're doing. Let's do another one. I think we just have to get one more done and then we're on track with the other class. I'll give you guys a little extra time so you're not too far ahead. Any questions on 3A before I do 3B? Same idea. What am I going to factor out here? Tangent, very good. So I'm going to take tangent of x out, and I'm left with √2 cos x minus 1 equals 0. We took tangent out of everything. Again, I'm going to set both of my factors equal to 0, and I'm going to start by doing tangent of x equals 0. And then I'll do my √2 of cosine of x minus 1 equals 0 momentarily. Where is tangent 0? Remember that tangent is the same thing as y over x? And for tangent to be 0, the only way for that to happen is if 0 is in the numerator. It's not 90 and 270.
180 and first.
Mm-hmm. We want the y to be 0, not the x to be 0. Mm-hmm. 0 degrees and 180. Remember, we're not going to use 360 now because I want to go up to 360, but I do not want to include 360. Okay, so that's our tangent 0, 0 and 180. Now for the other one, I got to get cosine of x by itself. So let's move our 1 over, add 1 to both sides, divide by √2. So cosine of x equals 1 over √2. Ooh, that's not on my unit circle. What's that the same thing as, though, on my unit circle? √2 over 2. If we rationalize it, this is the same thing as √2 over 2. So I'm asking, where is cosine positive √2 over 2? 45 works, and give me one more. 315, very good. So these were positive √2 over 2. So I could not do cosine in the second or third quadrant because those are negative. So I had to do in the first and fourth quadrant. So my answers are 45 and 315 and 0 and 180. So I'm going to write it in nice, pretty order. 0, 45, 180, 315. All of these answers count as answers. Okay. That's where we're going to stop for today, even though we're done a little bit early. The other class took a little bit more time, so we'll give you the benefit to do your 4-7 homework, to do something else, to take a breather. When we come on Monday online, I'm going to pick up here, and I hope to finish this and get into 5.2.
I got this is not a question.
I'm going to stop recording on